Now let's look at heat flow in a two-dimensional system, or you could say between cells in a grid. So I've got a grid set up here where the boundaries are at 25 degrees Celsius and everything in the middle is at 10 degrees Celsius. We're going to watch the middle warm up. I've got a heat transfer coefficient. Again, I just picked this number pretty much out of thin air. And I've got time starting at time 0 here, and I've got space for dt, and we'll see how we're going to deal with that in a sec. And we know we're going to need the derivative of the temperature in each location, so I've got another whole grid set up over here to record that. And depending on how you want to treat your edges, you might want them to have a derivative of 0 all along the outer edges. Or you might want them to be slowly heating up or slowly cooling down or something. So for Excel and math reasons, I'm saying let's say all the derivatives on the edge cells will have this value at all time steps. So the first question is, how are we going to compute the derivative, let's say, of this cell? How fast is its temperature changing? So we're going to do pretty much the same thing we did before in 2 dimensions and even in 1 dimension and even 0 dimensions, except do it in 2 dimensions now. So I'm going to say equals my heat transfer coefficient times, and what we did before was the cell to the right minus my current temperature. So this is at x location 1, 1, and y location, x location 1, y location 1 here, x location 1, y location 1 here. And then we did heat transfer coefficient times the cell to my left minus my current temperature of my own cell, plus the heat transfer coefficient times the cell, you could do above or below either one, minus my own current temperature, and then plus the heat transfer coefficient times the cell below me minus my current temperature. And you might be thinking, wow, that's basically the same thing over and over again. Is there a way I can streamline that? Sure, you can move the heat transfer coefficient out to the front. You can even group like terms if you want. And those lead to some insights that can be interesting, but you also don't have to do those. You can just spend the time to type it all out like this. And that's good for now, so we'll do that. And so we got a positive value there. That's good because this cell should be warming up because it's next to cells that are warmer than it. And then if I paste that, copy and paste that everywhere except the boundaries, I get that. And then to put in the boundaries, I'm going to say equals my edge temperature derivative, and I'm going to press F4 on a PC or Command T on a Mac to put in the $sign. So I'm just always referring to that no matter where I fill it. So notice that each of these is referring to that number. And we'll fill it over there. We'll paste it here. Whoop, let's try that again. We'll paste it here. Paste it here. And paste it there. So now I have a bunch of derivatives, derivative values, one for each cell in the table, and then the question is, how am I going to update my old temperatures to get my new temperatures? So I'm just going to take a copy of this whole thing, and I'm going to paste it down below. I'm not going to put it right next to it. I'm going to have a system here. I'm going to say, well, my grid starts really on row 10 and goes to row 20. So to maintain that spacing, maybe I'll say my grid starts on row 30. Except I copied a little high there, so I'm going to undo that. Okay, so now my actual grid numbers start on row 30 and go to row 40, just like they went from 10 to 20 there. I'm wasting a little bit of space here, but it's kind of nice to have the row numbers be working in a system like that. So that's just pasting, kind of saying where I will put stuff, but now I need to actually put the stuff. So how are we going to take old values and derivatives and make new values, well, we will use the calculus prediction formula, which is equals previous value plus rate of change times delta t. And I'll put my delta t here. I'll come back to that in a minute. And here's where we need some clever Excel magic. I know I'm going to need to fill this left to right, so I'm going to put a $sign on the B there. So when I change left to right, I'm going to keep referring to column B. I'm also going to fill this up and down, and so I'm tempted to put a $sign on the 10, but then when I fill this even farther down to do more grids farther and farther below, it's going to keep referring to this one cell, and I want it to be able to slide that to some extent. So I'm not going to put a $sign here on the 10. I'm going to fill in a new time here. Let's say time 0.1. I'll compute dt to be the new time minus the old time. And now here's the clever part. I'm going to say equals the cell above me. So I'm going to get a bunch of copies of dt here. I'm going to take this value or this cell and paste it everywhere. And now if I look at which dt it's using, so it's using the corresponding cell here and the derivative, and it's using the dt, which is the right value. And then I'm going to take all these and copy them there because I'm going to need that in future iterations. Don't worry that they're negative now. We'll take care of that in a sec. So now I've got my updated values based on my previous values and my derivatives. And I'm going to copy all the derivative stuff and try to paste that in the right place. And that's good. I got things exactly lined up. So now those derivative values are using the new values here. And let's do a conditional formatting before we go any farther. We can highlight this. It's up to you whether you want to include the edges or not. I've just decided not to here. I'm going to do conditional formatting, color scales, and let's use red for hot and white for not so hot. All right, and now the big thing is, how are we going to do even more grids? And the nice thing about Excel is if you highlight stuff that it doesn't fall in a pattern, it will just repeat what you give it. So I'm going to highlight here all the blank stuff. Actually, I'm going to start over here. All the blank stuff between these two systems of grids, all the way down to the last row of my actual grid here. Then I'm going to copy, like autofill. I'm going to click on this and drag down and go maybe 1,000 rows. It doesn't really matter. And I am getting some really large and negative values there, so I must have done something wrong. I will take a sec to look at that and figure out what I did. Okay, here's part of the problem, I think. So I had set time here to be 0 and then time to be 0.1, but then when I filled down, it didn't really know what to do with this 0.1, so it just added 1 to it, and then it added 1 to that. So it's taking time steps that are bigger than I want. So what I'm going to do to tell it what time step size to use, I'm going to say this cell equals, actually I'm up here, I'm going to put my desired dt, I'll put 0.1, and then I'll say here equals the previous time point plus my desired dt, and press F4 on that to lock that. And now I want to copy that formula into all the right places down here. I can't just drag it down. What I have to do is the same way I filled up the grid space thing before. So the last blank row, the first blank row here all the way down to here, highlight that, and then I'll drag that down. And now I'm getting reasonable numbers there. I probably don't want the kind of half grid here that I just, whenever I let up on the mouse button, that's what I got, so I'm going to delete that. So that's a way I can see the heat spreading in from the edges there. You might wonder, can we make graphs of this? Well, you kind of can. You could highlight like the x locations and some cross-section here and make a scatter plot. So that's a cross-section temperature graph. You could do the same thing. Oh, it looks like the y locations are messed up, so we should go fix that at some point. I guess I'll show how to do that while we're here. The y locations, we can just say equals the number above it, and then we'll fill that down, and then highlight the blank stuff plus all the stuff I just did, and fill that down. Okay. Okay, so now my y locations are good, and then I can take another cross-section graph by doing this and something like that. Of course, I should be labeling these. Alright, so that's the basis of heat flow. We can do another interesting thing we can think about. Instead of heat flow, we can think about pollution. We could say, well, what if I had an ocean that had no pollution in it? So I'm just going to put 0 pollution everywhere. And let's say someone dumped 100 barrels of oil right there in the ocean. And then we see some of that's going to spread out in various directions. And so the next time step I have not still 100, but 88 apparently. And then some has spread out, and then we can watch that spread out. I'm going to jump down here. So there's still not very much at the edges, and there's some still in the middle. So that can be kind of interesting. It's interesting that pollution spread and heat spread are basically the same mathematically. That's it.